Mitigation NDMA on the stage to kindly take the chair. It is with great pleasure I would like to invite Dr. S.P. Aggarwal, Director, National Eastern Space Application Center, NESAC. I'll also like to invite Mr. Krzystoszek McIntosh. He is CEO of Methera, based in UK. I would also like to welcome Mr. Paul. He is Solutions Director, Government, Defence and Space, APAC, Intelsat. He is based in Adelaide, Australia. We thank Mr. Chris and Mr. Paul for taking time and coming all the way to India to help us in our space capabilities. I would like to welcome Dr. Rajashekhar N and Rajashekhar N. He is DIG in BPR&D. So I'll introduce the chair and the panelist, and we'll request the chair to address the gathering here, and then we'll request all the panelists here to speak for about 8 minutes. In the end, we'll have question and answers because this is a very technical subject and it relates to everyone, disaster management. And in the end, we'll request the chair to give his closing address. If it is okay with you, I'll start with the chair. Mr. Safi Rizvi is my batchmate in the IPS. He's had a wonderful career in the state and also in the center. He's a graduate from prestigious St. Stephen's College and Indian Institute of Management, Ahmedabad. That was still the academy, and I don't know what all he has added after that. And he's served with distinction. Actually, he served with distinction in Intelligence Bureau, and he raised this intelligence in the economic vertical single-handedly. And today, it's a very powerful vertical within the Intelligence Bureau. We met together in many DGP's conference, and we've also shared dice together. We have made presentations together, and he's extremely sharp, and he's had a wonderful career, both in the center and the state. He was also OSD to the Home Minister, Mr. Chidambaram, and wielded considerable influence in the Home Ministry. Now, Dr. Rajashekhar N is a scientist SG in ISRO. He is an experienced Earth observation and space science expert with over 20 years of leadership in providing critical weather support for space launches. Holding a PhD in meteorology and oceanography, he has a certificate in space studies from International Space University. He specializes in space launch operations, Earth observations, and technology development for natural hazard early warning. He has led teams to deliver essential data for satellite missions. He is dedicated to leverage space technology for sustainability, innovation, and societal well-being. The next expert is Dr. Shiv Prasad Aggarwal, who is currently serving as the Director of Northeastern Space Application Center, NESAC, where he has utilized space technologies for natural resource management, infrastructure planning, disaster risk management, weather forecasting, and other applications. Earlier, he was Group Head of Water Resource Department of the Indian Institute of Remote Sensing, which is located in Dehradun. He has made significant contributions to the United Nations affiliated Center for Space Science and Technology Education in Asia and Pacific, which is also called CSSTEAP. He is the President of Indian Society for Remote Sensing, ISRS, and contributes significantly in this field academically and also professionally. He has received several awards and accolades during his career. Dr. Aggarwal is a highly accomplished scientist in the field of remote sensing and GIS. Then we have Chris McIntosh, who's a MSc MBA and Chartered Engineer. He is presently CEO of Methera, an early-stage satellite company that is developing highly flexible and multifunctional satellite services. Earlier, he served as CEO of Viasat UK, where he led inception and growth of Viasat's European space capabilities. He's a retired British Army officer who has served for 35 years in high-threat cyber and satellite communications environment. He holds a MSc in Design of Computer Systems, MBA, and is also a chartered engineer. He has led many innovations as CEO of Methera. We have Mr. Paul, who's come all the way from Adelaide. He's a disaster recovery system expert. He launched this Ready Connect, first portable VSAT. He's Adelaide based, and he's done tremendous work for the Asia Pacific. And he's an expert in geosciences, and he's also monitoring seismic activities in the Asia Pacific. He's a mechanical engineer by training and also a postgrad in business. He has over 20 years of experience in this field. And our youngest panelist today is Rajashekhar N. He's an IPS officer of 2007 batch Nagaland cadre, who's presently a DIG in Bureau of Police Research and Development. He holds degrees in commerce, political science, and police leadership management and law. Additionally, he has earned diploma in cyber laws and forensics and also business law from National Law School, University, Bangalore, which is a very prestigious university. In his earlier tenure, he served as SP in CBI, and he has handled anti-corruption and economic offences. He has also served as the principal of Central Detective Training School based out of Hyderabad. In his state also, he's also had a very fulfilling career. About myself, I have been a DGP of Himachal Pradesh, which is a disaster-prone state, for 4 years. And my experience in disaster management also comes from my tenure in Ministry of Water Resources, where I was Joint Secretary, Policy, Planning, and River Development. I used to deal with disasters also, both floods, droughts, and all kinds of disasters, climate change also. So additionally, government entrusted me with the responsibility of chairman of Brahmaputra Board, which is the largest river basin in India. I was also chief of the National Climate Change Authority. It's called National Water Mission, and also chief of the National Water Interlinking Authority. So that is my experience, and I don't want to stand between you and the chair. I'll request the chair to kindly come and give his opening address.
Thank you, Mr. Kundu. It was lovely to meet you after so many months. We have worked together for a long time, so we understand the policing part of each other. But for both of us to have been on the ground for so many years and suddenly talking about the space and things much above the sky so high is a very different world. It is a very interesting subject that we have been invited to discuss today. It is an extremely interesting panel that we have, where we have, I shall definitely sit on the back and not take a very active participation, but I'd just like to lead this discussion, which I would request the moderator, Mr. Kundu, to moderate. We have a government officer, a middle-ranking government officer who essentially is doing all the work. That's why middle ranking is not a bad word in government, it's a very good word. That's where you do all the work, that's where you learn. Then we have a high-ranking officer from this, a scientist from the space world of India, ISRO. And NESAC is the Northeast ISRO. ISRO in the Northeast of India covers about 8 states. They do a lot of work there. Then we have two very expert people from the private sector, one from UK, one from Australian companies, and they will add all the practical latest technology availability on the subject. And then we have a scientist from the private sector, second to my right, second from the right, I would say. So overall in disaster resilience, I'd just like to paint a picture, the policy picture. So I work at NDMA for about 2 years, and we also look at National Institute of Disaster Management. So over the years, we have seen a sudden and a very, very big increase in need for space capacities. And then when you get into space capacities, the world is very immense, very intense, very deep. Just grappling with the three-dimensional problem of how deep do you go into spectral expanse, how deep do you go into the spatial part, whether it should be sub-meter or not, is that really required for your purpose, and how do you organize the temporal passes, which satellites do you connect to, which are passing every day, do you need imagery every day? And then the fourth dimension is added, is which hazard are you talking about? Like Mr. Kundu spoke about floods and landslides, there are also earthquakes, there are also cyclones, also hurricanes and various other disasters. Government of India has specified 12 disasters as listed, that these are the 12 we focus on, and they've recently added lightning and heat. So there are 14 formally classified disasters. So that's the fourth dimension that we have to look at on the policy space. So discussing aspects of this would be a good idea. Then one other big thing is that the need for government is very high, because disaster response, disaster resilience, disaster mitigation doesn't get that much interest from the private sector as one would have thought it should. Government is the main person holding the burden for that. So price of the products that come from the private sector is a big problem. The price has always been very high. However, it is gratifying to note, while at tea, I went to some of the stalls. They are saying that prices have come down to at least half in the last 5 years. So when we started telephony, we started at 16 rupees a minute. Today we are possibly at 0.16 paise a minute. So competition and spreading the use of a technology is the best way to move forward for reduction of price and evangelizing the technology. So on these two aspects, if Mr. Kundu could take this discussion, and whatever else he wishes to add, he's been my very good friend and he has full license.
Thank you, Shafi. These are very nice opening remarks, and we have a perfect mix of scientists, policy people, private sector. So I'll just give you my experience. In 2023, Himachal Pradesh suffered the worst disaster in a century. There were floods, there was erosion, there was landslide, there was a mudslide, earth sank, almost everything happened. Except for earthquake, everything happened. And we rescued more than 1 lakh people. That included about 5,000 foreigners also. So a lot of these foreigners, their ambassadors actually thanked the government of India here. So when I got into discussion with someone, they're very happy that we could save all the foreigners. And the present Navy chief's son was also trapped there, we saved him. They said, what is development about? Is it only about GDP? They say that's very incorrect and not complete explanation of development. Development means, should I be in trouble, will the authorities reach me and rescue me? I think we demonstrated that. And India is increasingly demonstrating that whenever disasters happen, we are able to rescue people, we are able to address them. You cannot bring down the disasters, but you can actually address them. You can respond to them properly. But I would not like to come between us and the expert. I'll hand over the mic to Dr. S.P. Aggarwal, who's an expert who's devoted his life in remote sensing and GIS.
Yeah, thank you. Let us talk about the disaster risk management. So you are aware that disaster has different phases. So I will talk something on the different phases, then different space technologies available with us, and beyond the space technology available to us. So what is the new technology trends are there in that? So let me start with the disaster risk management. Basically, we have to be prepared for the disaster. So there's a disaster preparedness phase. And then comes the response during the disaster, what you can do. Then after that, post-disaster, what you can do. And then mitigation phase. If you look at the preparedness phase, now India is well prepared. In fact, I can tell you with the help of space technology. Now, space technology is having 3 basic segments for disaster risk management. First and most important segment is the Earth observation systems. You may be aware that currently India is having more than 15 satellite Earth observation, 80 satellite in communication. So Earth observation provides us the information, what is the current condition. Earth observation provides the information that what has happened in the past for 20 years or 30 years. And based on that, we can prepare the hazard map, whether it is a flood or landslide, whatever it is. So we can clearly know that you can make a hazard map of the flood, you can make a landslide inventory map, what are the frequent, landslide prone areas, what are the frequent flood prone areas. These things you can prepare, these maps you can prepare, so that you can do through using Earth observation data. But then, during the disaster, which is very, very important phase, and that time actually all three things are required: Earth observation, satellite communication, and satellite navigation. So, we have different satellites, so we need to know what is the exact location of different areas of the disaster, whether it's a flood, whether it is a landslide, whether it is a earthquake damage. If you want to look, then we should have a different kind of satellites. So we have satellites for total inundation mapping of flood. If you want to do, we have a satellite of resources satellite. But if you want to know the detailed information about the damage, detailed information about the landslide, then we have a satellite of Cartosat-1 with 2.5 meter resolution, Cartosat-2 with 65 centimeter resolution, and Cartosat-3 with 30 centimeter resolution. So detailed information can be provided. But during the disaster, rescue and relief is very, very important thing. And for that, we need a services of the satellite communication and satellite navigation. Many times it has happened that whenever there is a big disaster is happening in a place, communication is lost, terrestrial communication is lost. No mobile tower is working, no electric power supply, no diesel or generator is working for the mobile tower, so you cannot communicate. I can quote one example of 22-23, when during a heavy monsoon in Dima Huzai in northeast region, that district collector could not contact. Can you imagine? District collector could not contact that Guwahati headquarter, that what is actually going on in Dima Huzai district. And only that time satellite phone helped them. So satellite communication is very, very important aspect of disaster risk management. Then satellite navigation is also very important. We have to know the precise and accurate location of the disaster. Okay, there may be some localized based disaster also, there may be big disaster. Without that, you cannot plan for helicopter sorties for relief and rescue. You cannot plan, nowadays drones are another very important aspect. In fact, my team is involved in that. During the Silchar flood, satellite data, because whenever flood comes, there is a heavy rainfall, and heavy rainfall means heavy cloud. So optical sensor will not work, micro data is not available. Then what to do? So I have sent my 2 teams to this Silchar area, and I can tell you that they have done a wonderful job, and they could able to locate even individual houses also. And with the help of those maps, state government, what they have done, they have sent relief material to even individual house. But you will ask me how to send during the flood time material to the individual house, because helicopter sortie will be there. He will drop the food material. But then how? So then for that they use the advanced drones. So if you have a drone, so drone is another very important aspect which complement the satellite information or satellite imageries. Then third thing is the IoT. IoT is also very, very important, and it should always be linked with the total, this is nowadays I'm always calling it there is a need for disaster risk management. We should have sensor wave. What is sensor wave? Sensor wave essentially means we should have satellite information, including all 3 kinds of satellite: Earth observation, satellite communication, SATNAV. Then we should have drone information, we should have instrument information, and all these information should be combined using IoT. Okay, then it will go to a server, and that commissioner of relief and rescue or the ministry side also, people should have all these information. So if we will have all these information, probably this will really improve our, or this will reduce the disaster risk in the future. This is all from my side. Thank you very much.
Thank you, Dr. Aggarwal. India faces increasing climate and terrain-driven disasters. The integration of space-based assets with ground-level disaster response is no longer a luxury, but a national imperative. We have Mr. Paul with us from Australia. He's done tremendous work in this field. I would request him to tell from experience of Australia what we can learn and how we can integrate space into disaster response.
Good morning. Thank you very much for the question. Yes, when it comes to disasters, there are the similarities between India and Australia, which are quite vast. Both countries are extremely large, cover a lot of, obviously, land mass. We in Australia have witnessed, at any particular point in time, there could be one area of Australia that is affected by floods, another by bushfires. The only thing that is not really common in Australia is earthquakes, but severity of the disasters always affects the communities in the same sort of way, where the terrestrial services, terrestrial communication services are affected. So there have been so many lives lost due to the fact that terrestrial communications failed, and that's where satellite communication comes in. Company like Intelsat, which is a global company with global coverage, we can assist globally, but being regional to Australia and focusing on Australia, what becomes very, very important that voice and data are the critical paths to communication. To assist in the recovery, you really need voice in large volume of lines, telephone lines, but what's imperative also is the data for transmission of crucial information. The most crucial information, from my personal experience, is imagery. So if there is a flood affected area, there's nothing more important than understanding exactly what is the extent of the damage, where the effort needs to be coordinated to, and those maps are very, very, I guess, data intensive, so they're large files. So I distinctly recall a case from the massive tsunami we had in the Pacific in 2006, where the size of the map that was needed to coordinate the response was 25 gigabytes, and that was supposed to be sent to the coordinating committee via BGAN. So those of you that understand BGAN, where the cost in those days was something like $5 a megabyte, the entire transfer took overnight, literally, and cost many, many thousands of dollars. So speed of the links and ability to deploy that very, very quickly is imperative. My area of expertise is in communications. So when it comes to imagery and I guess other types of solutions needed to coordinate, we work with those companies. We work with companies that provide geospatial navigation, imagery, SAR, synthetic aperture radar technology. We work with all of these companies, but the expertise of Intelsat is pure comms, and we can definitely we were able to help globally, and where we cannot be on the ground, Intelsat, having access to over 60 satellites globally, is very keen and very, very willing to donate bandwidth. So there have been many instances globally through the disasters, and there was one in the Typhoon Haiyan in Philippines, where Intelsat simply opened the telephone lines, was able to take calls and donate bandwidth free of charge to assist with the coordination efforts. So hardware was handled by ITU, bandwidth by Intelsat. The response was done very, very swiftly. So having access to the satellites globally, having access to a lot of capacity, also makes us able to respond very, very quickly through work that we do with the clients, like defense, which is my area of expertise. We can actually offload those solutions to the recovery efforts as well. So it's not just bandwidth, it's not just access to the data, but we do have a plethora of portable, quick deploy, very capable solutions that we can then throw at a particular solution or disaster and say, look, here you go, we can donate that and assist with this, just like happened in Florida during the latest typhoon, or so it was a tornado, where houses were torn apart through rain and landslides, and our staff turned up with the vehicles equipped with communication devices and provided comms for the loved ones to make sure that they check on each other's well-being. So across Asia Pacific, I think I've spent a good part of 15, 20 years solving communication problems for the disasters and preparing for the disasters, training Asia Pacific engineers in how to use this technology. But one thing I can say, disasters are unfortunately bring grief wherever they occur, and they're very similar wherever they occur. So bushfires, landslides, rains, floods, they're all tragic. But one thing is common, is that satellite communication becomes the common denominator for the most effective way to coordinate the response.
Thank you, Mr. Paul. Dr. S.P. Aggarwal brought out the overall picture of disaster and the space connect. And Mr. Paul said how robust communications is extremely important in disaster. And his company, Intelsat, has been doing this. We'll now go to Mr. Chris, who's CEO of Methera. And before this, he's headed 2 companies as CEOs. He has a lot of experience. Now, the objective of this session was how satellite technologies, including Earth observation, SATNAV and SATCOM, are strengthening disaster preparedness, response and recovery. The discussion will highlight user-side challenges, demand gaps, and the growing role of industry in delivering device and service-based solutions for resilient infrastructure and emerging management. So what are your thoughts on it, Mr. Chris?
Thank you. Since Paul just managed to steal most of my thunder, I'm going to change the actual gist of where we are and where we're going. And so, as a company that right now is in development stage and therefore has the flexibility to change what we deliver in the future, we are very focused on, therefore, what is changing. So, what is changing regarding disasters, which will inform the capabilities of the future. And we're all, well, we or I, relatively old. We've got to realize that the young people of today are very different from us. We all rely on voice, and voice seems to be the most important communications for us to move forward. But things are changing. When we talk about disaster areas, connectivity is far more than voice. Because now, the experts, when it comes to disaster relief, are often hundreds, if not thousands, of miles away from the actual site. The kit, the equipment that they're using, the equipment that is actually capturing live data on the location, has to remotely send back that data to be analysed in maybe another country or even another continent. So yes, we talk about GPS, we talk about voice, we talk about what's going to happen on site. But the thing that's really changing is that a lot of the analysis, a lot of the decision making is no longer actually occurring on site. So having our stovepipes of connectivity that allow people to talk and to communicate is great and essential, don't get me wrong. But we've really got to start thinking about how are we going to connect the systems of systems that actually affect the people in that disaster area. And what that means in essence is, we've got to start thinking about, yes, we can have stovepipes, but how do we connect them all together in that area? And so, for example, Methera, one of the things we're doing with our family of terminals is looking at terminals that can take different types of connectivity and turn it into the types of connections that we can all use. So, for example, we like to be able to provide Wi-Fi bubbles instantly at any site, very quickly. And so, when you look at the end user's equipment, it can be as simple as a mobile phone, regardless of what the actual interconnectivity is into that location. And what I'm trying to get at is that it's not just being able to talk one-to-one, it's being able to receive, whether it's imagery or the results of analysis, real time. And that's what's becoming key. And the decision making, which is now spread and diverse, is not just a case of people being able to literally talk together to make decisions. It's computers, it's individuals, it's systems that are all over the place. The other thing that's changing quite rapidly, because of the way that information knowledge is shared so quickly, is the fact that any large disaster rapidly becomes an international problem. And that's because all the countries get involved, because no doubt there are people involved in that from different countries in an area that's a disaster. They want to know what's happening, they want to get a foot on the ground, and very quickly you end up with a complete mess regarding the management of that disaster, because even the national home team have to fight and struggle to ensure that they have control. So yes, there are lots of different areas that have to be considered when it comes to disaster planning and moving forwards. I believe, and Methera firmly believe, that connectivity is at the heart of it. And our reliance on systems, our reliance on the internet means that we've got to very quickly reinstate communications and connectivity as quickly as we can. Thank you.
Thank you, Chris. We have an expert with us who's launched many satellites, and he's an expert in weather forecasting also. Dr. Rajashekhar, I just want to throw a point to you that India is increasingly witnessing consequences of climate extremities. Can we have a space disaster mitigation nexus? Can the country's maturing space capabilities directly inform our disaster risk governance? Because I see a disconnect. You are doing a very high-tech job, but the practitioner on the ground is not connected to you. Your thoughts on this?
Thank you, Sanjay. The first point where the climate change is enhancing the disasters and its severity. So the concept has come, now it is the early warning systems. So connecting to the early warning system and early response to the disasters. So where the satellite data is majorly influencing the accuracies of the predictions, especially for meteorological related aspects, and connecting to the space technology where we have the national missions as well as the commercial missions like constellations of satellite, optical, SAR-based, or now we are getting the hyperspectral imaging. So those things are going to very quickly able to locate the disaster and give the information about the disaster to the administrators or a disaster management team. So where I'm giving the examples where the early warnings, you see yesterday there is the Himachal Pradesh flood. So every monsoon we have in the foothills of Himalayas we have the flood. But these are predictions. If you see the early warnings 3 days, 4 days, even 5 days before there is a predictions. But it is coming to that administrative level. It is not coming that information in a proper way what they want. So where we have seen the state government administration, the impact, what is the impact? The weather is going to happen, some disaster is going to, what is the impact? So the information, whatever the state government or the administration need, the impactfulness information has to go. So second one is once the disaster is been early warning we predicted, the information is been with the administrator, then we have to alert, we have to make the system, the observational system. The flood is coming and the communication, the satellite-based communication we have to establish, and the flood, what is the intensity of the flood, what are the satellites? Within 1 hour, even current available constellation of satellite, within 1 hour we'll get the flood map. But we are not using. So I think we are in a good shape of monitor or predicting the disasters, but we have to fusion the total data and things we have to keep in the right position, and administrator has to take the right decision. So resources we have to keep, there is a framework we have to keep. As the institutional way, where the flood is coming, what season it is coming, early warning. So institutional way you have to bring the system and it is going to impact. So there are resources, it should be in the proper streamline. So I am giving one more example. Spain floods might have been listened last few years back, last year, and LEA fires. The developed countries also, they have the early warning system, but they are unable to act as India is acting as a disaster is happening. So because of climate change, in the globe, any country going to experience the disaster, extreme weather, extreme disasters. So they have to experience, they have to get the data, they have to utilize the early warning system, they have to streamline and make the streamline flow and get the information and to take the action. So same like Australian floods and whatever we have seen the floods in India. So recently we have got the Vijayawada floods last year. There is only one satellite data we got from Sentinel just before the breaching of the rivulet. After that, we don't have anything. So that also data come from the CWC. So if you want to see the data, always we tell data is not there. But early warning system, we have to use the early warning system. Predictive analytics, we have to go. We have to task the satellites, even private or government, we have to trigger, get the data, real time you can monitor. So the thing is, again, I am telling, we have the resources, we have to connect the resources in the form of early warning system to the monitoring system. As our Srivastav sir is telling IoT sensors, even flood is coming, IoT sensors may not work. Satellite data we have to depend on. So we know the disaster is coming, we should get the information and all. One more information I am telling about landslides or earthquakes. So using satellite data, synthetic aperture and interferometric satellite data, we can see the small deformation we can see in that particular location where recently we can see the glacier, the collapse of the glacier in Switzerland. They able to evacuate total village months before. How? Because they monitored the satellite data, that small deformation has been observed and they evacuated and the disaster has happened. So the use of satellite data, we have to use that way, the landslides as well as the earthquake zones. We have to monitor satellite data continuously and we should know, and then we have to implement in the ground. So this is the point.
Thank you, Dr. Saab. When we were in the ministry, we had started conversations with Google. Like you have Google Maps and then you have traffic maps also. Can Google have something for flooding, drought, and other natural disasters? We had initial meetings and they said, yes, it is possible, though it is very complicated. Some countries have tried. But as Mr. Rizvi said, the list of natural disasters is only increasing. From 12, they've gone to 14. So my question to the youngster here is, what are his thoughts about governance, interagency coordination, and data availability? And because he is working in BPR&D and he deals with police, I'll request him to give his thoughts on this.
Thank you, sir. First of all, some of the statistics, 65% of our Indian land is prone this one. And in 2021, there is one World Meteorological Department which says that $87 billion have been lost due to the disaster. And regarding international cooperation, one is the Sendai Agreement in 2015, where it is for 15 years, that is up to 2030, where there are 7 targets, especially on the disaster management, like identity, reduce, and risk transfer. Risk transfer also includes about the insurance and all those things. When it comes to the disaster management, of course, there is a keyword called PWRR, that means preparedness, early warning systems, and the response and the recovery. In the preparedness, as one of the panelists has been said, that is the hazardous zonation maps, even for the landslide, even for the floods, even for the other things also, these hazardous zonation maps have been made in India, this one. Even for earthquakes also, seismic microsummation, drought, flood, and all those things. Apart from this, there is one National Disaster Management Command and Center which gives keeps all the data. For the early warning centers, especially for the cyclone, cyclogenesis is there. That is one of the concepts that has been there. We get to know that before 5-6 days also we get the proper information about what are the cyclones that have been coming. And one of the most accurate predictions of the Indian Meteorological Department is the extreme rainfall. Even before 2-3 days also they can give the extreme prediction, not only that one heat wave, cold wave, and for example, earthquake, not much has been done, but the earthquake precursor studies have been shown that some of the accurate this one. As far as the weather, sir has already spoken, there is another one organization called International Charter Organization, where the nations have been come up across and they use the satellite data of one of the other. One of the example is that in the Polaram West Godavari, this one dam, this one, we used the satellite data given by the French, this one, Pleiades, that satellite. Like there is another organization called Sentinel in Asian, this one. Talking about the glacial, that one sir has already spoken because of the climate change and all those things. There is one thing called National Glacial Inventory. And remember, very interesting, 35,000 lakes have been under this inventory, and 5 top of glacial hotspots. And there is a concept called GLOF, GLOF. They come up with glacial lake outburst flood that has been come. And one of the example is the Chamoli flash flood. And interestingly, Chamoli flash flood has happened not because of something else. It has happened because of the rock slides. And one of the important thing is that only because of the satellite data we came to know what is the cause of this one, the rock slides and all those things. That is the importance of the satellite this one. So, and also regarding the vulnerability assessment. Now, 200 districts, there is a vulnerability assessment as far as the landslides is concerned. And Rudraprayag is the one which is the topmost, and Cyclone and Kerala and Jammu and Kashmir and even Himachal Pradesh have been come in the topmost this one. As far as the warning of the landslides is concerned, there is a concept called interferometric star technology which has come up in the recent years, this one. Apart from this, even for the natural disasters like forest fires, and now the lot of forest fires have been, satellite data able to know what is the extent that the damage has been burnt area and smoke affected area and all those things. And now Government of India has come up with some geotagged apps, especially with the help of the IRSS, where forest fires have been this one that will help the evacuate the persons and also this one. Apart from this, even for issues like air quality in Delhi, sir, air quality in Delhi, Punjab and all those stubble burning and all those things, what is the amount of air quality, pollution, biomass stubble and all those things. From state space data, we are getting the proper this one. And in 1998, we can recall that Vijayapara cyclone that has happened in Odisha and all those things. Of course, we could mitigate the less damage to the human cause because of the early warning systems and all those things. But damage to property, we could not this one, but at least the loss of lives could have been minimized because of the thing. Of course, we have the NAVIC satellites in the, as far as the oceanograph. Of course, we have the oceanograph satellites, ResourceSat, Cartosat and all those things. NAVIC satellites for the fishermen and all those things. And Indian Government of India has come up with a national database for emergency management support services. This is a very important fact from the common man point of view. What are the support services? They will get it from the this one. So the National Disaster Relief Fund and the State Disaster Relief Fund and all those things. We can get back to another one is in 2013 Philippines, where the floods have happened, and regarding a private industry, some UK based industry came up with some virtual satellites. They put up umbrella kind of a thing and all those things, and each one given 5 minutes to talk to their counterparts or who are there in the other districts. This is one classic example. Another example for the international cooperation and the industries that happened, earthquake in Haiti as well as in Turkey, where we can see the cooperation between the national and the industry and the other this one. So these are some of the areas, this one now, especially in Northeast, if I come to the Northeast, since I'm working. So one of the thing is that preparedness. What we find is that we are not learning from the past, this one. Only there is a mock drill of the state disaster relief management. That time we will came to know what is the problem, especially with the interlinking or the coordination between the administration, police, and the SDRF or the NDRF or whatever it may be. And the same things get repeated even if you do the mock drill the next time. So something to do with that, our people has to be constantly trained and actually prepared for this one. The preparedness holds the key, especially in the this one. We have this automated forest fires, this one also apps that has been come up in this one. So regarding the satellites and all those things, a lot has been spoken by the experts. We have the ResourceSat, Oceanograph, Cartosat. Carto means mapping, and all these ReSat and all kind of geosynchronous satellites which have been constantly using. ISRO is doing a wonderful job in this one. Some of the other challenges that may come, and we can involve the industries, that what is the security that has been involved, mapping and all those things. Of course, one of the thing I heard, I don't know, the experts may this one, even if you want to get a map of a particular data, it takes a lot of time. So only when the life and death is involved, then only we will get it on priority. That is one thing that is, especially when we conclude the other areas also, when you include other areas, can we get the maps and all those things in a very early this one so that we can go and all those things. Maps are very important, sir, because in the flood prone areas, if there is a block spots in all those things, that shows that the amount of area that the flood has been gone. Even after a few days also, after many years, we can take the data and predict what kind of, for example, example, there is a huge rainfall, then I can say these are the areas that are likely to affected. So this is the one of the main challenges with the private industry and the international agencies and the other space agencies, and even sometimes even the aircrafts. If you don't get the satellite image, then whichever the aircraft is flying over the disaster management area, then we get the pictures from that aircraft. So we need a lot of private industry, private aircraft, or the private space agencies, French or whatever it may be, that requires to be come into the picture for the better management of the disaster, not only India, but all over the world. Thank you so much.
Thank you, Rajashekhar. So we have the chair who's advisor in NDMA. I like to pose two questions to him before we throw the house open for questions. What about innovation, AI, and public-private collaboration? Is NDMA thinking about it? As he said, disaster management is largely a sovereign job. Second is there a case for national mission for geospatial disaster readiness under the NDMA?
Questioning the chair is not a nice thing, but since you are, so that's a very interesting point, and I will weave it into what everybody has said, and then I guess we have to wind up in another 5-6 minutes. On the AI part and the geospatial part, what Government of India does through its National Disaster Management Agency is that the 15th Finance Commission in its 5-year period provided $30 billion over 5 years. This was divided into 4 windows. A 10% window for preparedness and capacity building, which is what institutions that train. Then a 20% window for mitigation, reduction of risk. So this 10 plus 20 is all pre-disaster. Most of the discussion we've had today is rather post-disaster. What do you do in response? What do you do in relief, reconstruction, after the disasters happen? So still 70% of the funds are post-disaster. That has also been cut into 2 windows. The 40% is instant response and relief, like the NDRF goes for response, then relief assistance you have to give to the people who have lost their homes. And 30% goes for long-term reconstruction through a means called post-disaster needs assessment. So how geospatial gets into all 4 of these windows is obviously a very complex part. But one of the strands I will take from what Dr. Rajashekhar said and Mr. Rajashekhar, the younger one, who told us about 72 things in 6 minutes. So you have a deep breadth of knowledge, and I think we should discuss in detail with you because you seem to know a fair bit of the stuff. So is the word interferometry. Now, one of the biggest lacuna in India where the space industry, this is how you can bring the private and public together. One of the biggest lacuna is that most of the companies who come to us at NDMA tell us about how here, see, there is a glacial lake disaster happening, and in almost real time we can give you, this is the way the water is flowing. Now, as a policy person, I will say, okay, now the water is flowing, it's done, the disaster is over. Now I have to go back to pick up the pieces, so thank you, I will tell NDRF to mind these spaces and go only to these spaces. But what about all the people who have died? What about all the infrastructure that has got washed away? So the big game is interferometry, where you can figure out what is happening to a slope from just simple geospatial intelligence or analysis using AI, ML, whatever the fancy words that we use these days. And interferometry has been shown to be done. NESAC does it, ISRO does it, NRSC, the National Remote Sensing Agency, does it, Indian Institute of Remote Sensing does it, and several private agencies are doing. But what I'm seeing is that of the 7,500 glacial lakes, there is nobody, whether Indian or from overseas, who is coming up with a product that is selling interferometry to the state governments. This $30 billion, 70% of it resides with the state governments of India. You just have to go show them that product, that I can sell you an interferometric product, say in a state like Himachal Pradesh, where you can actually see that your 1 centimeter movement in your so-and-so landslide hotspot is happening, and now it's speeding up, so that's where you can take preventive action. And the same for glacial lakes. This is a huge gap where the public-private sector can come together. The second big thing I notice here is what Christopher was mentioning about how if the disaster is happening there, the analyst is sitting elsewhere. So the other elsewhere that has come up is in space now. So there are a lot of startups that have put up their stalls in the halls nearby, which are telling you that edge computing can go right up onto the satellites. So that is one thing that they are doing, is that they're doing all the analysis in space. So it is saving you 99% downtime of downloading all that expensive imagery and doing your analysis down here. So they have produced it, the product is available, and it is just that it's not been mainstream because it's too expensive right now. So for the normal private sector to start using this product, it is too expensive, hence it is not growing in scale as it should. So that is another space where the private sector that works in the space needs to come in. And the other thing that is happening now is very interesting, where you don't need to launch your own satellites. There are a lot of satellites that are around that are open for hire. You can hire space on that satellite, and you can borrow space from, say, 100 satellites, and there are companies right here in that hall who are demonstrating this, and you can get your analyzed product in your hand. So it's not about map making anymore. It's all about using the cloud and using machine learning and making standardized processes by which you can again and again analyze disasters that happen or the ones that are going to happen. So in a nutshell, I've very interestedly listened to what Christopher said and what Paul said about how if communications are basically going down or they are slow, that's where your problem starts and ends. So when we have our discussions with the CDRI, the Coalition for Disaster Resilient Infrastructure, these are the three main things they talk about, that disasters impact communications, number one, transport, number two, and energy infrastructure, number three. 70% of the infra damage is to these three sectors. So communications in all our response efforts, we find that's the first thing we have to attend to. However, the most interesting part is that Indian agencies are able to come up immediately. The BSNL, which largely operates in all the areas that are not very reachable, they do it in 6 hours, 8 hours. If it is really essential, they'll take 4 hours to do it. But it's a fairly good turnaround time. The power sector in the coastal areas, max I've heard is 24 hours. So these are pretty good things, fairly good for resilience, fairly good for how quick you can snap back to your original position. But yes, for everything there is state for improvement. But the message to the private sector, SIA is essentially a coalition of the private sector, is that please evangelize your products, try and take it down to people, not just to companies and governments. If you take it down to people like insurance, and there are 1 million people investing in your product, you will be able to reduce your prices much faster and make it a much more acceptable product. So with that, I'll hand over to the moderator for his final words, and then we can close up.
See, it was an interesting session, and we're open to questions now. We can take a couple of questions, yes, please.
Well, my question has partly been answered, but it is more of a concern and a question. As Mr. Rizvi also said that 70 to 80% we are devoting our resources towards mitigation and response. As far as prevention is concerned, one is, can we have a live hazard, being projected in the area for the local administration to pick up, and the warning period should be sufficient so that they can relocate or do whatever preventive activity needs to be done. Second thing, with my experience in the disaster management, has been that the first and foremost issue comes with casualty evacuation. It is basically you have to save lives, infrastructure you can handle later on. And the moment you start pulling out the injured or the dead or whatever, there are sentiments involved, but their medical response has to be the first one there. And it is the medical response cannot come because again the connectivity is not there and even preparation is not there. So a large number of casualties happen because A, we did not predict it in time and we could not relocate, and secondly, we could not respond to it. So the short question is, how can we improve our warning systems, and what is the current preparation as far as the space is concerned and as far as the civil administration is concerned?
That's a never-ending question. 10 years later when we meet, we'll be asking the same question. But if we take you back to 1999, which is 25 years ago from today, the super cyclone in Odisha had killed 10,000 people, 10,000 on record. And it had wiped out the coastal areas of Odisha. And today, 25 years down the road, as was mentioned on the right side of this panel, you get 7 days early warning for a cyclone. At that time, we did not have proper integration of our satellites, Earth observation satellites as ISRO, with IMD's ground stations, with various other modeling structures that they have now. And now with this mission MOSON, they're going to have atmospheric assessment of Met data. So with all this, you have 7 days of warning. Now the fight that we have with the IMD is that, oh, your track that you predicted did not go like this. It was only 97% right from the time where you didn't even have a track. So early warning has reached that stage in cyclones. Early warning may not be there right now in landslides and glacial lake outbursts, which is what I spoke about. SAR interferometry is a space where the private sector can come in, and maybe you can have 100 websites offering user ID, password, sale products that look at interferometry on the mountain next to your home. And it's so easy. It's just that, and it's not even focused on the kind of imagery, the spatial imagery you're getting. You don't have to be sub-meter. You just have to be the guy who understands how SAR interferometry is done on your computer. So that is another early warning stage that we would like to go to. For earthquakes, we are working on early warning for earthquakes. You would say, how is that possible? Where every earthquake emits 2 kinds of waves, the pressure wave and the seismic wave. So the P and S wave are different in the sense that the S wave is slightly slower. So when the P hits the Himalayas, God forbid, and in Delhi, you get about a 30 to 40 second advance. So in that 30, 40 seconds, if you can shut off your automated systems, like slow down your metros, have some beepers and warning systems. So even for earthquakes, there is a possibility. So these are all things that we are consistently and continuously working on. This question will always remain, and we will continue to answer, and we continue to run alongside our friends in the ISRO and our friends in the IMD on the subject.
Thank you very much. I have been told by the organizers that I need to wind up, but I can take that question. Yeah.
Hello, good noon to all. My name is Jigish Patel. I am Group Director, former Group Director ISRO. My question to Mr. Paul and Rajashekhar. Let me explain my question. There is a 3 kind of basic satellite, LEO, GEO and MEO. And 2 of it, that is a polar satellite. And basically works on the remote sensing and active remote sensing, RISAT. And third one is a GEO that is having one environmental module like VHR and all that. Now, Mr. Rajashekhar is told about the fusion of data. So how we can go for the efficient fusion of data for all 3 kind of payloads, polar satellite and geostationary satellites, so we can have the quick disaster warning. That is my questions. To fusion of all 3 kind of satellites. Especially Mr. Paul from Intelsat also gives answer.
I'm sorry, the question is how to integrate data from multiple orbits. Well, look, in fact, I would turn the question around as a solution, because this is one of the strengths of multi-orbit solutions these days, that the solutions become more resilient through multi-orbit. And I was actually going to mention that previously, where, to Chris's point, that the coordination is changing, that the use of data is changing to be more extreme. And that actually is quite intensive for geo operators. So this is where multi-orbit solutions become very, very cost effective and far better for resilience. Latency is far better on LEO, that's no doubt about it. So that's superb for voice. But when it comes for data intensive and always on and reliable comms, I think geo solutions are superior. So to have access to all from an operator that can provide you technology on the ground, as in antennas that are multi-orbit, that would, for me, constitute an ideal solution not in any situation, not just disaster recovery. So this is what we specialize in. This is for defense, this is for disaster recovery and commercial applications. Multi-orbit is a far more superior solution these days.
Yes, I agree totally with what was said there. But additionally, it's not just satellite. We say multi-orbit, there's things happening on Earth. There's analysis all over the place. And what we've got to do is we can't keep on segmenting where data is collected as to whether we're going to use it or not. The whole beauty of this interconnected systems is that we bring the data that's required to the right places so it can be analysed together to come up with the correct results, instead of stovepipe, 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 and having 18 decisions to make. We've got to get all the data in the right place so we can make quick decisions that are consistent.
Thank you very much, everyone. I wish to thank the chair, all the panelists. It was a very nice session. We could have carried on longer, but there are pressures for the next session. And thank you, audience, for such patient hearing.
Thank you so much, sir. As a token of gratitude and appreciation, we now present a mementos to our eminent panelists. May I now invite Mr. Safi Ahsan, sir, please. Yeah. To our moderator. To moderator, sir. Yeah. To Mr. S.P. Aggarwal. To Mr. Krzystoszek. To Mr. Paul. To Mr. Rajashekhar N. Yeah, yeah. Yes. To Mr. Rajashekhar N, sir. Now may I invite Mr. Ravi Alwadi, sir, board member of SIA-INDIA, to please present the mementos to our chairperson. Please come forward to the group picture, please. Thank you so much. So now we are starting our next session. So this session is going to be about EO digital twins for critical infrastructure, energy, utilities, and smart cities. So just give me 2 minutes, so we'll just settle down our dais. Then I'll call upon our moderator. Moderator को set down. For this, I have privilege to invite our session moderator, Captain Vishal Kanwar, Managing Director, PwC.